All right, so if you haven't had enough of me, here we go again. If you have, it's only 15, 20 minutes. So we're going to be talking about going beyond vendor-based zero-touch provisioning. So if you weren't in the last talk, my name is John Anderson. I'm a network automation engineer at Networks Code. All right, so what is ZTP? So zero-touch provisioning in the context of networking is the function of a network device to retrieve a configuration and or a software image on boot with no human intervention. So the idea is you plug in power, you plug in a management port, we go to DHCP, and we get some information on where to get a configuration, and we load that. And that's kind of the extent of vendor-provided ZTP solutions. Now, in the year 2019, almost every vendor has something along these lines. Most all of them are DHCP driven, as I mentioned. Some offer the execution of Python or Bash scripts, so instead of retrieving a text-based configuration file that you would normally interact with, you can have the device go and pull a Python script and it'll execute it locally. And we'll talk about how we can leverage that. And most of them have the ability at this point in time to retrieve a configuration via HTTP. If they don't do that, you can fall back to TFTP or FTP. So the point we're going to make today is that these solutions are a good start, but they can be hard to scale. So we're going to talk about how we can build a bigger automation platform around this so that we can scale these solutions up and be multi-vendor aware. So what's the problem here? So most ZTP methods are DHCP driven. So, like I said, your management address boots up, goes and makes a request for a lease. DHCP server is going to offer a lease and it's going to have some special options in it. And one of the early problems you'll run into is each vendor is a little different. Each vendor uses some different options. So like Juniper loves option 150 and 43, and Punilis loves this option 239 thing. So most vendor examples use hard-coded DHCP config. So if you go to Juniper's website and you look at their ZTP solution, they're going to show you this DHCP config that you throw in DHCP. And it's going to be hard-coded, so each device is going to be mapped directly to a pre-generated config in their example. So they just take the MAC address of the management interface and they tie that in the config directly to the pre-generated config that it's going to go and pull from some source. So again, if you're that by the serial number of the MAC address, sometimes that's okay. So if you only have 10 or 20 devices that you want to do this on, that may be a more appropriate solution for you. But if you're going beyond that scale, particularly if you're interested in this solution where you want to do this on site, and you have multiple sites, then we need to look at something a little bit different. So here's kind of the 35,000 foot architecture of what I'm talking about here. So this is really based off a system that I've built in the past and have kind of augmented over time to do some more interesting things and be a little more robust. So we've got our devices here, we've got our DHCP infrastructure, then we've got a workflow automation engine. And in this case, I'm going to talk about StackStorm. So if anybody's familiar with that, that's an event-driven automation platform. It's particularly big in the networking space because they have some direct integrations with a lot of networking stuff in what they call packs, which are just modular things that you can import different actions and workflows. We need a source of truth, so we're going to pick NetBox. Then I'm showing this Slack thing, chat ops. And the point there is we want this to be interactive with the operators. Now, we don't want the operators to have to do anything, but we want to keep them up to date with how things are going. So we can have some chat ops integration there. So we'll dive right in. We only have a few minutes, but I'm going to go over the basic workflow and talk through some things. So device boots up. It's going to grab a DHCP address, and the DHCP server is going to say, and via some options, you need to go and get this thing called init.conf, and it's going to be on this HTTP server at that address. The device says, okay, I'm booted, I'm going to go make that request now. And again, this is just the vendor built-in solution. So we're going to go talk to that HTTP server, which happens to be a Python Flask app, which is running in a sensor on StackStorm. So back up, talk about that. So Flask is, like Django, it's a more lightweight Python framework. Very appropriate for this use case. So what we're actually standing up is a web server written in Python, and it's running inside of StackStorm. So StackStorm has this concept of sensors. Sensors are the function of StackStorm to look for events. They can wait for events to come to them, or they can go out and poll systems for events. And when an event happens, it's going to fire a trigger into StackStorm. It has a rules engine that's going to determine what it needs to do with that event. That's the very basis of event-driven automation there. So our device is going to make an HTTP request to this Flask server. That Flask server is going to serve that device, the HTTP or the init.conf, and that init.conf is going to contain some very generic, very basic access config. So it's going to enable like SSH. It's going to throw a super user on the box, and that's pretty much it. So the idea there is that's very generic, and that will apply to any device that comes here. And the point there is that config will get overridden in a minute, but we need StackStorm to be able to get into that device. So in the next stop, StackStorm has an integration with Napalm. So we're going to use Napalm to go back to the device and collect device facts. And StackStorm knows the IP of the device because HTTP is wonderful. We get the request address as a part of that. So we inject that in our trigger into StackStorm. So StackStorm knows where to go to talk to that device. We're going to use Napalm to collect facts. And we're looking for like the serial number, the model number, just some metadata about the device. That's important because we need to go and use that data to go to our source of truth, that box, and query for the intended state of that device. So prior to unboxing the device, powering it up and all that, we have defined what this device's role is in our network, in our source of truth. So we've represented it as a device in that box. We've created its interfaces, we've given its IP addresses, there's the VLAN mappings and all of that sort of stuff. So we go there, we use the serial number and the model number and all that we pull. We pull all that information down from NetBox. This is StackStorm doing all of that. StackStorm is then going to pull in our configuration templates. Those could be in Git, or they could just be directly in the box, what have you. And we're going to take those configuration templates and the data that we pull from our source of truth, and we're going to render our device config. So if you've got, if you're using Ansible to do this sort of configuration management today, StackStorm can integrate directly with that. It can execute those playbooks directly. If you have a larger network automation platform already, you're doing configuration management somewhere else, that's fine. StackStorm can actually just go and say to that configuration management system, give me the config for this device. And then it doesn't have to render anything. But in this case, we're showing that we're going to pull in those configuration templates, all that data, we're going to render that final config, and we're going to use Napalm to push that config to the device. And if the device accepts that config, it's all good, it's happy, then we're going to go notify the humans that the operation is complete. And I'm not showing it here, but the same concept applies for like software upgrades. So we talked about in the first slide, one of the early things is, a switch can pull a configuration. You can also pull a software image and do an upgrade. We do the same sort of thing here. And the interesting point that I like to make is the source of truth should really define what software version the device is supposed to be on. So rather than having hard-coded in our DHCP config what version we want new switches to come up with, we tell the device, don't use your native ZTP function to do an upgrade. We're going to have StackStorm do that for us. So we just use the normal upgrade methods. Like we're going to SCP the image to the box, and we're going to do the upgrade on box with StackStorm. So that allows us to get whatever version NetBox currently defines for that device. So we don't have to go through an extra upgrade just because we have some old version defined in our ZTP process. So takeaways here. So we're using the vendor-based ZTP function to retrieve an initial config that triggers a workflow in a larger automation platform. So this allows us to stay vendor neutral. Now you might be saying, that initial config isn't going to work for Juniper and Cisco. I can't have the same config there. Okay, well, what we do is we have two different HTTP endpoints, or however many, n number for the different platforms or vendors that you want to support in that Flask app. And so you have an init config for Cisco, you have an init config for Juniper, and the umpteen different platforms that you may need to make that work. But the point is, when the device requests a DHCP address, we can use those vendor options in that request. The HTTP server can map that to the appropriate endpoint that the device needs to go to. And so when that request comes into StackStorm for a particular vendor endpoint, StackStorm now knows not only the request IP that the device management address is on, but it knows what platform that device is. It knows if it's a Juniper device, Cisco device, or whatnot. Why is that important? Napalm has this concept of drivers. So Napalm has to know some level of context about what type of device it's talking to so it can pick the appropriate driver, because the way Napalm communicates with Juniper devices is different than the way that it talks with Cisco devices. So it has to know the difference there. And so again, the way that we're doing that is we have two different HTTP endpoints. A Cisco device goes to the Cisco endpoint, a Juniper device goes to the Juniper endpoint. They get those initial configs. Those configs really do the same thing. Again, they're just enabling SSH, putting a super user on the box, something like that, so that StackStorm can then come back later. And so this allows StackStorm to be vendor neutral. Well, not StackStorm, but the whole platform to be vendor neutral in this way. Now the other major point to take note of here is, in my example, we're generating these configs on the fly, or we're talking to a configuration management system to generate that config on the fly for us. Your mileage may vary in this case, like I said. Sometimes pre-generating the config may be okay for you, depending on the size of the deployment that you're going through. And oftentimes, this solution, while cool and all, might be a bit much to undertake for like day zero operation for you. So we can step into this over time in this transition phase. And so maybe pre-generating the configs beforehand makes more sense, in which case you're just automating the DHCP config. And that's what that gray line between StackStorm and DHCP is supposed to be showing there. So again, for smaller deployments, things like that, that can be a little bit easier to manage. Managing DHCP config at scale can get a little weird sometimes, but that's why in my example we're generating those configs on the fly, because this really is meant to tie in the larger automation platform in which we're doing configuration changes over time. That's the whole idea there.